Now, the second way we're going to perform this vector product between A and B is by utilizing Cartesian components. While it may not be as fast as the previous method, it is a lot more rigorous. It works every time. And it's especially useful when vectors, it's kind of hard to determine the direction. So here we have two arbitrary vectors in 3 dimensions. One of the difficult things about this is they're going left, upwards, and out of the page all at the same time. And it makes it really, really hard to draw them and do things like figure out the angle between them. So sometimes it's best to just use these directly. Now, this cross product that you're going to be asked to perform can be done without needing to draw a picture at all, using a tool known as a determinant. However, I don't think anybody, at least in this particular version of the course, has ever heard of a determinant before. So what we're going to do here is we're going to use basically a down and dirty method of getting our answer out of this process. We're going to do something that's equivalent to a determinant, but doesn't involve any fancy matrices or anything like that. So let's say we have our two vectors A and B, and we want to do A crossed with B. Keep in mind the order here does matter. Well, the fastest way to do this is actually to take your first vector in your cross product, which is A, look at the Cartesian components, and write them out twice. So what we're going to do here is in a horizontal line, I'm going to go 1, 1, 2, and then I'm just going to write it out again. Let's just make it so that they're evenly spaced. All right, so what we have here is, actually I'm going to space these out a little more, is we have our vector components written out twice in a row. Underneath it, I'm going to do the same thing for B. Hopefully I can do this right. So 2, 3, 4, 2, 3, and then we'll get the last one in here, 4. Now, the reason we're doing this is we're doing this to line up our numbers. So what we have here is numbers in a row, and they line up with the ones underneath. Now, to perform this very, very quick version of the determinant, the very first thing we're going to do is we're going to get rid of the rows on the other side. So the row on the far left and the row on the far right, and cross them out. You're not going to use them. Now, at the end of the day, we're going to get a vector for our answer. So our vector is going to have 3 Cartesian components. And the reason we've drawn this is it sets up a way for us to find it. Now, to find the x part of our answer, or the first part of our answer, we're going to take a look at this first set of 4 numbers here. So we're going to just look at these 4. Now, what we're going to do here, I'll get rid of this box, is in order to calculate the x component we need, we're going to multiply down on the diagonal. Right, so, and then we're going to subtract an upwards multiplication on the diagonal. So if you multiply down on the diagonal, 4 times 1 is 4. And then from this, we're going to subtract the upwards multiplication. So from this, we're going to subtract 3 times 2, which is 6. And that's what we're going to do to find the x component. Now, you can do this very quickly. 4 minus 6 is negative 2. We're then going to repeat this process for each set of 4 numbers. So we're going to move over to the next one. We're going to do down multiplication minus upwards multiplication. So for this next set here, what we're going to end up with is 4 minus 4. Just color code these right. Which gives us a result of 0. And then we're going to do the last set, downwards multiplication minus upwards multiplication. All right, so going down, we have 3, and then we're going to subtract the multiplication upwards on the diagonal. So here we're going to have 3 minus 2. And if you subtract these out, what you'll get is 1. Now, this method here actually gives you your final answer. Again, vector C is going to be our answer. It's going to have 3 Cartesian components. The first one is going to be negative 2, the next one's going to be 0, and the last one's going to be 1. And with this, we found the resultant of the cross product. At no point in time did I need to draw anything. At no point in time did I really need to think about anything. All I did was take a look at my numbers and arrange them in a form that's convenient for me to multiply this out. I actually quite like this because if you take a look at what you're doing with your sets of four numbers, what you'll notice is in that set of four numbers, you make almost like a little cross, which is representative of the cross product. Now, I can't take credit for this. This is not my method. I was introduced to this by Dr. Vasiliev in a linear algebra class. And the whole point of it is just simply to make this process of finding the determinant of a 3 by 3 matrix a little faster. And it's one that I recommend that you go with.